So cool, science! Are things of different heights able to fall at the same rate? Now, that's a wicked cool question, and today we're talking pendulums. And my favorite pendulum of them all is that seesawing, nauseous-inducing, gut-spilling pirate ship ride. You know, the one that'll have you, feeling like a drunken sailor early in the morning. And today I've got a wicked cool demonstration that you can do right at home that's almost 500 years old, but it's still just as solid as gold. And of course, all you're gonna need is an everyday common vegetable can. Because the vegetables are gotta be useful for something. You eat the wheat, I'll eat the meat. All right, get yourself 2 vegetable cans, tie a rope around them, double knotting it, and then hang them so that they can freely rotate back and forth, making sure they're both at the same height. And now you're ready to turn some hang time into some swing time, because you're gonna pull one of the cans back further than the other, and then you're gonna let them both go at the same time. So cool, instant replay! Wow, now that's so friggin' wicked cool, man. They both cross the center point at exactly the same time. Now that's so friggin' cool. See, I bet you thought like one can was gonna fall faster than the other, and then they were gonna kind of swing back and forth the opposite direction. You're not even gonna know they were gonna be swinging at the same time. You were gonna be doing something. So, why do the 2 cans line up at the bottom exactly? And why are pendulums, well, so important? Well, don't look at me. Take a closer look at this. In 1583, Italian scientist Galileo experimented with the consistency of pendulums' periods by comparing the movement of swinging lamps in a cathedral with his pulse rate. He discovered that the swing of a pendulum is constant. It always takes the same amount of time for the weight to swing out and then come back again. The weight will eventually move in shorter distances, but the weight still takes the same amount of time to complete each swing. The reason the 2 cans cross at the same time is why balls will fall faster or slower depending on the angle of the hill. He also found that the mass of the weight doesn't affect the period of the swing, so long as the length of the string is not affected. A longer string will have a longer period than a shorter string. Scientists in 1656 used his findings to make more accurate clocks. Earth's gravitational field is not the same everywhere. A pendulum swings faster at Earth's poles than it does on the Earth's equator. So now you know more about oscillating bobs. Being able to test pendulums right at home is why science swings.